So first of all, thanks for having me here in this year's online edition of sambaXP. So this obviously led to a lot of location information on my title slide. So forgetting for Senate, Mainz, where I'm currently located, and Kelzerbach near Frankfurt, where actually our office is, and where we are currently working on Samba for Spectrum Scale. So yes, thanks for having me here. Some information. Every couple of years, I think I turned out on sambaXP with some news from our work on Samba and Spectrum Scale. So I'm working as an IT architect at IBM, and I started with the predecessors of Spectrum Scale, and my current focus is here on Spectrum Scale and the Samba integration. So which basically means managing customer requirements, managing development priorities, integrate with all the IBM internal teams for the file system, of course, gpfs, but also to interact with with Nfs, with object, test teams, project management, and so on. And I'm very deep in the customer level 3 support. So that means at least analyzing issues and defects, and again, turning that into requirements and new development work items. Prior to that, I started on a couple of Spectrum Scale's predecessors like Sonos and V7K Unified. Prior to that, I had some background on cell processor, parallelization and vectorization of algorithms, and I started actually out in the Mainz production plant at the analysis of complex production networks. So we had a wafer line there that did the read-write heads and disks actually for hard disk drives. But that's more than 20 years ago now. All right, so what do I have prepared for today? So basically a quick overview of Spectrum Scale. Then I'd like to go briefly about the important features and contributions that are important for our customers, and so that Samba and Scale and gpfs work well in their environment. I have one performance sample slide of a customer I'm allowed to show here. And then I'd like to mention the major work items we are currently working on. So there are, besides also support, defect fixing, test, and so on work, we currently have time to work actually on 3 major development topics. And then I'd like to open the field for authentication requests, which are currently under investigation, which caused some headaches at customers. And let's see how this goes. And of course, we will run across the names. You all know Samba team members like Christoph Schmidt or Martin and Amite in former days, who of course are a part of the team. And what you will notice when we go through the slides. All right, Spectrum Scale. Some of you might have seen this chart here. So the picture, basically, it's all centered around gpfs, which is a cluster file system started in IBM research in 1993. And so it has evolved over time. Sven this morning in his keynote actually had pointed out the point where he had started to put Samba on top of it, or actually on AFS in the beginning. So it's beginning of the 2000s years. And since then, things have evolved. So there's a VFS module for gpfs called VFS gpfs, which is handling some of the subtleties with timestamps, with leases, oplogs, and stuff like that to integrate well with gpfs. And that actually was created in 2006. And then the line of history actually goes along with what Sven showed this morning already. So there were predecessor projects like Stonehenge. There was SOFS, a solution offering by IBM in 2007. There was a NAS appliance called Sonas in 2010. And there was a smaller one of these NAS appliances for unified file and block access in 2012. And finally, we started Spectrum Scale in 2014. So even if the names around have changed, and the base idea for the topic of this talk still is the same. So we have gpfs as a clustered file system, and we need something to export SMB to the outside world, and that makes use of the cluster features that gpfs brings along. And so as you can see here, these IBM products have picked up most of the Samba versions over the last 20 years. So Soft started out with Samba 3.2, Sonas 3.6 to 4.2, V7K Unified, Samba 4.3. And in Spectrum Scale, we started with Samba 4.5, and so we just G8 Spectrum Scale 5.05, which comes along with Samba 4.11. So we normally have half a year of release cycles and start with the Samba version, which is then out and stable. And so it looks like, well, actually we are lagging a little bit behind, but we try to stay recent with the Samba versions we are including here. So just looking at the picture, I think you get the idea. So you have a huge data lake, a single namespace on a clustered file system. And then for all the modern workloads, whether it's containerized AI workloads, whether it's HPC, there is some component that actually gives you access to the data, and ideally without copying, or that you don't have to copy the data around. So for example, for AI workloads, you can ingest the data over Nfs, for example. You can connect your HPC workloads via native gpfs clients of a project. You might have exports over objects or do analytics with HDFS. And so you're accessing all the time on the same data. There are also various replication mechanisms so that you can actually distribute your data around the world, that you can cache data. And of course, you can connect various storage backends, whether it's tape, flash, disks. And you have the integration of data lifecycle management. That means gpfs can push around the data for you from hot SSDs or NVMe to tapes for archiving. So all that's included in the Spectrum Scale. And for the purpose of sambaXP, of course, Samba and Ctdb are at the heart of it. And so, of course, we're using it for data ingest. People are accessing results for AI analysis workloads, but we also have customers that use it as an NAS product. So an engineering shop that is putting all designs and other team documents on their universities, and or manufacturing plants putting out data from the manufacturing line in 24/7 environments. All right, so let's move ahead. So 2 slides on what are we actually using of Samba and what our customers do like about that. And for most of these areas, we also provided significant contributions with the team. So of course, we are doing the file server part, but we don't have Active Directory. So basically, we're talking about SMBD. And so over the last couple of years, we are heavily hitting that with regression test cases. So we're claiming support of 20,000 concurrent SMB connections in a cluster. So we have set up a decent workload within a test appliance that spawns 20,000 client connections and runs things on a cluster for a couple of days to see that we don't lose a single connection on this long-running tests. Furthermore, we also make sure that we don't regress on performance. And obviously, there's the focus on metadata-intensive workloads. So we are tarring, untarring large archives. We are looking at directory listings, which of course is a challenge in clustered environments. because if you want to be precise, you put a lot of burden on Ctdb. And so we also run tests like SpecSFS and SIO workloads to make sure that we don't regress from one release to the other. And we also making sure that we do not hit any data integrity issues. So there's an IBM internal tool which writes data, reads data, copies data, and makes sure that all the data is correct. That means verification of these things so that we don't corrupt data somewhere within Samba. And this has been running regularly since Sona's days. So that means for the last couple of years, so that we actually can also contribute to some good coverage. It's not upstream, but at least, of course, if we find issues, fixes will be committed back to the upstream branches. Next important thing, of course, is Ctdb. And Martin already mentioned this morning. So what was missing for a long time is that upstream is actually testing Ctdb as well. So this has been changed at least with some basic tests. So that will allow us actually to see breakage earlier and get quick feedback and hopefully fixes if things go down. Then Volker has done an item that's called DREP no log on our end, which basically means that we are trying to avoid holding logs in Ctdb and in the file system at the same time, so that we don't end up in deadlock situations where we get stuck and don't get out in a recovery. So, for example, if a node goes away, Ctdb wants to do recovery. There are some logs in that we don't release because at the same time we also have logs in gpfs and things get stuck completely. So this is rather new. And besides that, obviously there's a constant stream of fixes, enhancements, and ideas that Martin and Amit just presented. So that's the Ctdb part. Obviously important for us is WinBind. So most enterprise customers have Active Directory around. So we're also heavily relying on WinBind. One of the features we had to add is overlapping IDMap ranges. So it's nice if you go to a customer and say, well, you now have to do different ranges for your different domains, but customers will tell you, well, we have mappings already, but they are not easily subdividable into certain ranges. And as such, we added that feature that actually we can handle that. Of course, it means some searching and asking various domain controllers in the backend, but this is a feature that is quite frequently used. In our environments, we normally do the support cases based on static log data we capture from the customer systems. So if customer tells us, well, something hangs, obviously we have no chance normally to jump on the system immediately. So we need to have some proper log messages. And we started in WinBind to add time auditing to see when WinBind is hanging, why this could be the case. And at least the parent WinBind has this already. The work for the child is still pending. More features customers like, of course, Nfs V3 ACLs. So this has been stabilized, but every now and then customers find some corner case that is working differently under Windows than it's on Samba with a POSIX backend and with the gpfs Nfs V3 extensions. So that's something that is quite heavily used and exercised. Obviously, customers want to see what's happening on their cluster. So we needed performance metrics. So those were added a couple of years ago. So we added some data in there. There's still room for improvement. For example, things like client-specific data, but that's currently not available. We put this data into time series database on the Scale system so that the customers actually to browse the graphs in GUI and so that you can see after the fact what has happened, what kind of workload was run, and how these things actually evolved over time. Snapshots are important for us, so customers make heavy use of it, and so obviously like the inclusion in the Windows Explorer. Another important thing is the cluster-aware change notifications. So that's a contribution that was not done by IBM, but of course the notify daemon is around, and it allows actually to get change notification on or for clients that are triggered by changes on a different cluster node. Mac support is important. So I think a year ago we put out VFS Fruit to our customers. So thanks for Ralph and then all the work he put on that. So of course it's not an IBM contribution as such, but a year ago we actually started to support that features for our customers so that they actually can use it. And we finally noticed this year for Mac clients that the Mac actually has changed. And so up to, I think, a year ago, Mac clients were able to deal with a file ID 0, but that does not work anymore on modern Mac clients. So we currently generate a proper file ID based on the gpfs inode generation and snapshot number so that we get a unique file ID to the Mac. And the Mac does not screw the file identities anymore. And finally, one thing we made sure that it works is immutability, so that you can actually use immutability over SMB. That means if you set the last access time with a Windows client to a future time, and you set the read-only flag to yes, then actually the file becomes immutable, and you can clear the flag once the time has arrived and the immutability has actually expired. All right. Some throughput numbers. And so I think Sven this morning said he wants to see that we can do 2 or 3 gigabytes over SMB. So we have one customer, the University of Queensland, which allow me to show this slide. They're actually getting close. So this is a Samba workload, single stream. I'm not quite sure how threaded this is, but it's as I said, it's definitely single stream. No metadata, of course. And so they are using 100 gigabit Ethernet, and by reading from a scale system through Samba, they get 1.3 gigabytes per second, and writing onto the scale, they get 1.8 gigabyte per second. So I think there's probably still room for improvement. So this is just setting up a scale cluster, tuning the network and everything, and run Samba as is in our config. So there's no special things on the Samba side like IO Uring we discussed this morning or other things. So this has all not happened here. So there's room for improvement, but out of the box with Samba, they get to these numbers after having tuned their scale cluster. And I think that's a good starting point for further investigations. All right, the ongoing work items. Those of you who have followed Volker Lendike's work, either in the form of commits or on past conferences, there's one case in support we are always, I wouldn't say frightened, but which can raise headaches if customers are trying to access a single file through many clients. Many means typically hundreds or thousands in our cases. So I think the most impressive thing we have seen was 14,000 clients reading a phone book exe file. And so this means in a clustered case, we have a couple of Samba nodes denoted as N1 through an queue on this slide. And each of these nodes actually can have, in our case, I think we support up to 3,000 SMB clients. So you can have, and there's an upper limit overall of 20,000. So you can have quite a bunch of SMB clients coming in through different nodes. And Martin already showed this morning, basically we have the Ctdb layer. And in this case, for each open, the SMBD wants to look at a record in the locking TDB to store the open file metadata and to actually add the opener of that file to an array. So if you have 10,000 openers and all of these clients have the file open, this array gets quite long. And if then the clients keep open and closing the files, Ctdb has to shuffle around that big record in the locking TDB down there. And obviously that's an inhibitor for performance. And there are some mitigations I will show on the next slide, but basically Volker has started to think how we actually can get around this issue. And so basically the idea is that you just cache the most restrictive share mode that needs to be checked on an open on each of the nodes. And so that you don't need to look at the long array. And if you can just check on this cached share mode, that it doesn't make any sense to go any further because the client will not be able to allow it to open that file anyway. You save a lot of record shuffling in Ctdb. And thus, of course, the whole cluster will have more headroom for other work to do because it does not unnecessarily shuffle around this network. So we've seen a couple of these cases, mostly from customers coming from non-clustered NAS, because in a non-clustered case, that's actually not an issue. So use cases for this are software patch distribution. We have seen firmware updates. We have seen address books, splash screens for CAD applications, workflow control files, and then shared project files. And all sorts of other things. And so obviously, this is one of my big desires to get this fixed so that we have a good answer to that. The answers we are currently having are presented on this slide. So what we normally do in these cases, either the customer has to put all the files which are heavily contended on a single export. And we actually do a proxy redirection to this export tied to a single IP address, such as all the clients actually end up on the same node. Obviously, this will put then all the clients on the same node, and this will require some data rearrangement normally on the client side, but that's one of the solutions to this problem. There are some other options. If you take a look at the file ID algorithm, Samba option in that man page of the file ID module, there are things like the no root year coherency. So we have seen that Windows Explorer likes to put a share mode on the share root. That doesn't restrict anything, but that is just there and will get shuffled around by Ctdb. So normally no one will actually mess around with the share root directory itself. So we can actually reduce that coherency on the share root share mode record and to get the burden from the share roots. For certain workloads where, for example, in media industry, where there are workload engines that control who is accessing which files, it might also be possible to use the no dears option. So that means no coherency on directories, or to do the coherency per node. But that, of course, requires certain precautions. And again, the real solution is actually the split of the locking TDB as described before, and you can see the details on the slides done by Volker. All right, one other work item we are currently looking at. So we have a lot of customers still running to do or wanting to do Nfs V3. And so there are two things with Nfs V3. Basically, you need to trust the client, but you need to do that anyway. But you get a list of clients, but that list is only for the groups, memberships, but that list is only of length 16. And so typically, customers want the server node to actually query the group memberships for users. And Ganesha has the option manage GIDs equals true for that. This means that basically in setups where we have Active Directory authentication, we have unauthenticated users, but we need to determine their group memberships. And so there are workarounds, and even Winbind implements those. One of those, you can take a look at the token group membership, but there are certain pitfalls, especially in trusted domains, where answers can be wrong or incomplete. And the real way to do it would be to use service for each self. And those of you who are watching what Stefan is doing, actually, he's getting this implemented so that we can actually determine group memberships for unauthenticated users on a Samba node. And finally, we had seen issues in flaky environments where domain controllers come up and go away, and Winbind takes longer than expected to actually determine that a domain controller is gone and to quickly find a new one, especially if DNS is also flaky. And if times are too long that the connection between Winbind and the Active Directory controller is broken, this might into either a loss of service or access denieds or wrong ID mappings put into the cache. So for ID mappings that couldn't be determined. And this caused some issues. And so basically we took a look, and it's a longer change, longer improvement needs to be done. But the first thing that we tried to tackle is actually to refactor the Winbind ADS file to actually move that to TLDAP. So there's a merge request out there. And actually, once we had put out the merge request, so Sven Schillich did that of our team, a longer discussion started around the LDAP integration and which is the right library and which has the right properties. So that is still ongoing, and we need to see how this turns out. But the base idea, and there's a high-level picture here, is really to get the Winbind more stable with respect to fault tolerance. So failing over from one Active Directory controller to another. All right, then finally, some authentication ID mapping requests we have seen from the field. One is centered around Unix identities, and the other one is centered around SSD support. And so I'll touch briefly those two things. So basically, ID mapping is complicated. So in the Windows world, you all know we have long sits. We have several domains. We can have usernames that are the same in different domains. And on the other hand, in even large enterprises, people have local LDAPs for their purposes. And somehow we need to put that all together. And there's no standard way. And obviously, there are mapping assumptions, something like, well, we don't have any name clashes in our Windows domain forest. So we can use the same name for a Windows user, just ignoring the domain, and can map that to an LDAP user or whatever. And as with Scale, we normally get in a situation where this is already set and we cannot start on a green field with proper identities. There needs to be a way to map all the stuff together. And WinMind has some features to get there, but I think one important thing is missing there. And so if we take a look at the general mapping questions, so basically we have a Windows identity and we have a Unix identity. And the question is on the scale, what is the username? Is it the Windows username? Is it the Unix username? Do we have a prefix or don't we have a prefix? WinMind offers the option use default domain, but this obviously has other implications, and it's of course not applicable to all customers because there might be customers around who have clashing names for different domains out there. Then we need to look at the primary group. So question is, do we have a Windows or Unix primary group here? And so trying to be or to follow the Windows semantics, initially WinMind took the Windows primary group, and this has actually changed a couple of years ago because we had many customers who wanted the Unix primary group to be the one applied to the Unix identity. And then the important topic of secondary groups. So where do we get them from? And so normally WinMind would try to map them. That means take the Windows token and see which of the Unix groups can be mapped to that. But this means that there has to be a mapping. And so the option that customers say, well, forget about the Windows token. We want our Unix identities and Unix groups. That's not easily doable. And this is one of the things that I think we need to focus on in the future. So here's a summary of that thought. So we have various ID mapping schemes in WinMind available. So that's the Autorit, the IDMap AD, IDMap LDAP. And so I talked about the primary group. So that's the selection of that has been added some time ago. So currently, we don't have a good answer for just doing the single name without the domain prefix. And the secondary groups using Unix token, ignoring the Windows token, that's also something that a lot of customers require. And finally, the SSD topic. So SSD started as part of the free EPA, and actually also was created in parallel to WinMind. So nowadays the question then is for our customers, what are we going to use? Coming from clustered Samba with NTLM and Kerberos, and from clustering, WinMind is a natural choice for us. And even Red Hat says on their web pages that so if you're doing clustered SMB and you need NTLM and you need clustering, then WinMind is a way to go. But nevertheless, at the same time, Red Hat tells people, well, we have to use SSD for security reasons. So for group policies, for sudo, for PAM and other things. And so this actually ends up the question, so how do you configure a Red Hat node where customers are following the idea of doing SSD when it's supposed to be a node that is doing clustered Samba? And so basically the question is, can we use either of these components, or can we use both of these components? Or has more development work to be done to actually integrate this to something that works at the end of the day? So if we take a look at what these components actually do, so usernames, we probably can come to some agreement whether we use fully qualified names or just the short username. And a switch is more difficult. The question is, who is first? And this is always a question because in the past, WinMind with Scale actually configured itself before SSD. Some customers want the other way around. And obviously, the question is, it does matter at some point in time. And so that's one of the issues we have to solve here. For system key tab, currently Spectrum Scale thinks it can use the system key tab, but this causes conflicts when sssd is installed in parallel. So we are currently thinking about getting our hands off the system key tab, using a private key tab for Samba and Ganesha in environments where we have categorized NFS, so that we don't mess around with the system key tab, so that we can perhaps resolve this this clash. Clustering. So for Winbind, we have a single machine account, and we get clustered password updates. So SSD is not clustered. So the question is, are you doing each node separately, or are you using the same account on all nodes? Basically, we have seen both ways in customer environments. Then we have also run across the SSD auto ID mapping, which is similar but not identical to what Winbind is doing for auto ID mapping. And so just in case that we actually have to do the SSD style auto ID mapping, it's also a question how this can be easily accomplished. And finally, the group resolution. So I said earlier, we are thinking about service for you to self here. But currently, Winbind and SSD both have the fallback to the member of and token groups. But there might be still subtle differences with respect to the accounts being used and with respect to cache time and other things that might lead to different group memberships in environments which are dynamic, where groups are added and deleted and other things. So there are some questions that need to be answered, and so I don't have a solution here today. But that's the current state of discussion. So I think the key tab thing should be solvable. Auto ID mapping we need to see, and the group membership, that's I think the big thing that needs to be determined. So who's first and a switch. Okay, so basically as a summary, so we have a long history with Samba and gpfs, and so this combination has greatly matured over time with respect to features, scalability, performance, usability. We have a lot of 24/7 use cases in production environments and in engineering environments, but there are still things on the wish list, and there's still some things currently in work in progress, which should make things better. And obviously, there's more on the roadmaps, like a concurrent upgrade, scalable drupal file handles, SMB optional features, listing large directories, and things like that. Okay, and having said that, I thank you for your attendance and can give room for questions. So, Jeremy, if you had some most important wish list items to improve, what would they be? Okay, so wish list is there. Okay, Jeremy, that question seems to be answered. Yeah, and I think the really most important thing I like is really that Volker is able to finish the locking TDB split. So that's because when you get out to a customer and customer tells you, well, I need to access this file with 10,000 clients, then it's good to have a good answer and not trying to set up something that works, but that is actually trying to use these special options or even that redirect. And then Andreas Burger asked, if you use member of for group resolution, how do you get the primary group? So I think there's a process within Winbind that is actually putting together the token. So obviously we get a Windows token when the user logs in, and then you would get a Windows primary group, and you might get a Unix primary group for some LDAP where you map against, and so I think that's where you would get the primary group from. So I hope this has answered the question. If not, please ping me and we can discuss further. Any more questions? Yes, so Jeremy is asking about SSD and WinBind. Yes, that would be great because this is really causing us headache, right? If we get out with Scale and with clustered Samba, with proper clustering, with NTLM, and customers tell us, well, Red Hat told us we should use SSD, and then we need to figure out how this can be done, and that should be hopefully a way for better, easier integration. And if it's that we at least get so far out of the way that we can use SSD for pseudo groups, for PAM, and all the stuff we don't care about, and that we can do the NTLM and other things with WinBind. So Andreas Hasenack is asking whether the slides will be available. I guess so. All right, 2 more minutes for questions. So there's one question in the chat. At page 8, you mentioned concurrent access to the same file over many nodes. What is the usual use case for this? All clients open file for reading, or also cases where many clients open the same for writing? Good question. So reading is typically one of the use cases. So just some file shared by many clients. But there's also writing. So for example, we had this phone book Excel that clients had to open. And when we checked whether this is just for reading or for opening, then people told us first, well, people read it. But after we really checked, they said, well, but there might be a couple of secretaries who are actually writing it. So that's obviously writing. So if you have the software patch use case, then that's typically plain writing. But actually, for the issue at hand that Ctdb is going mad, that does not help because with the current implementation, the SMBD will nevertheless check the share mode, even if you declare the file as a share as read-only, and if you just open the file for reading. So that does not really solve the issue. But of course, it would be good if we could exploit the read-only feature for certain files here. But again, we have seen writing as well. So for example, control files for applications that are running from various clients and store states or intermediate results into a file that is then opened by different other clients.